Hi everyone, Professor Christina Sover from Cal State Long Beach speaking here. And in this video, I wanted to go through an example together of what your textbook calls a story problem. Story problems are just word problems. And in this example, we have three folks. Dan, Lincoln, and Miguel are pulling their cash to see whether they have enough money to buy a game. They have a total of $46.80. As you see, I wrote it out in my imaginary money. Four tens, a five, a $1 bill, and eight 10-cent coins. They notice that Lincoln has twice as much money as Dan, and that Miguel has three times as much money as Dan. How much does each boy have, or how much does each person have? I'm going to write person here. So, looking at this, what we want to do is just figure out how much of this $46.80 does Dan, Lincoln, and Miguel each have. Um, I like to work this out in my mind as visualizing like each person's wallet, maybe. So, why don't we draw a visual of like a wallet? So, here's Dan's wallet. Sorry about that. And then we have Lincoln's wallet. I'm really just drawing a space to keep the monies all separate. And then for space sake, I have to draw underneath. We're going to have Miguel's wallet. And why don't we have his wallet be long? Sure. Okay, so we know that they have all their money. They're putting it together. That's why we're looking at all of their wallets at once. $46 is already taken care of. So the first two sentences we've already analyzed. But there's one very important information we haven't gone over. Lincoln has twice as much money as Dan, and Miguel has three times as much money as Dan. So, what does that mean? Well, if I take 10 cents and put it into Dan's wallet, then based on the statement that Lincoln has twice as much money as Dan, I have to put 20 cents into Lincoln's wallet. And from there, I also know that Miguel has three times as much as Dan. So I put 10 cents into Dan's wallet. I have to put uh, 30 cents into Miguel's wallet. Well, that's interesting. I just noticed, and let me get this off of the other picture, that every time I, divvy up the money between Dan, Lincoln, and Miguel based on the information given that Lincoln has twice as much money as Dan, and Miguel has three times as much money as Dan, I actually get rid of 6 units of the same amount. So that might be really helpful in actually going through and making all of my monies into equal sets of six. The first thing that pops into my head is I see the $5 bill and the $1 bill. That's $6. I can actually break up that $5 bill into 6 ones. So that's what I'm going to do. I'm going to exchange this $5 bill and get 6 ones. One, or not six, five. I already have, I took out five and put five. I can't make an imaginary extra dollar pop out. I misspoke. I apologize about that. So now I have six in total. I added five more ones, and I'm going to go through that process again. I'm going to give $1 to Dan. I'm going to give $2 to Lincoln, and then I'll give all three of these dollars to Miguel. My selection tool, it's not letting me pull them over. So give me 1 second. I have to go through and move them each one at a time. I really like working it out this way. visually because I think students would really enjoy to take the time to, uh, at least an example, go through and break up the money in this way. All right. The next thing I think about is those $10 bills. I'm going to break them up into fives because I know that I can manipulate and get six fives going on. So I'm going to return one $10 bill and get two $5 bills, one and two. I'll return one $10 bill and get two fives, one, two. I'm going to go through this process again, trading out a $10 bill and getting a $5 bill. Oops, I grabbed too much. Sorry about that. Well, we'll just leave that 10 for now because we don't need to actually break it up yet because I already have six fives and I can go through that process again of one five for Dan, two fives for Lincoln, and three fives for Miguel. Now, I know this is tedious, definitely, but it is helping to visualize the problem. Because I can't grab that without messing that up, let me get rid of those lines and then move that $10 bill up, and I'll break that up into two fives. One, two fives. Okay, let me put their wallets back in their spots. Now I have two fives and two sets of 10 cents. So I have to go through and break up this money even further. Let's just go with the fives. I know that I can break up the five into ones. So I'll get five ones. One, two, three, four, five ones. And this $5 bill goes back. One, two, three, four, five ones. And this $5 bill goes back. Same process as before. I'm going to give one to Dan, $2 to Lincoln, and $3 to Miguel. I have $4 left, and unfortunately, I can't play that game again of $1 to Dan, $2 to Lincoln, and $3 to Miguel. I have $1.20 left. Um, and so I'm just going to break up the $1 into, I'll do quarters first, and I don't actually have an image of a quarter on here. So I'll just draw uh, 25 cents, turn this $1 into 25 cents, 25 cents, 25 cents, 25 cents, turn this $1 into 25 cents, sets of four of those as well. And then I'll give 1/4 to Dan, 2/4 to Lincoln, and 3/4 to Miguel. I actually can do the same thing with those other $2. I'll change the color so it's a little bit different. So these two will give 8/4 as well. And I just want to say, I know this is taking some time, but some people might like to watch this. I'll leave the time signature of when we finish with all of this divvying up the money for this part of the explanation below. Okay. So again, a quarter to Dan, 2 quarters to Lincoln, and 3 quarters to Miguel. Guess it's a good thing we drew Miguel's wallet so big. We have plenty of space. All right. Now, for me personally, it's a little bit messy up here. I want to see how much money actually remains. So I'm going to go ahead and erase the money we've already gotten rid of into each person's wallet. And these $1 need to go back because we already broke them up. Okay. So now that that's all set up, we want to look at what we have left. We have 4 quarters and 2 dimes or 2 10-cent coins. I know that I can break up the quarters into 2 dimes and a nickel each. So why don't we do that? So 1 quarter will go away, and in its place, we'll get 10 cents and a nickel. Another quarter will go away, and we'll get 10 cents, 10 cents and a nickel. I'll do that again for the other 2 red quarters that we drew on the right-hand side of the screen. So that means I need to put 4 10 cents and 2 nickels. I hope we're seeing in this example well that it is very clear. It is quite tedious as well. And so it does take some time to get it all set up. Okay. Ooh, look at that. I see the nice cents, the 10-cent coins on the right hand side. There's 6 of them. So 1 to Dan, 2 to Lincoln, and those 3 to Miguel. 1, 2, 3. And then actually, if I want to go a little bit farther, I know that these 2 5 cents actually become a dime. So I can do that exchange. Same for the nickels over here. I can get another dime. And so I'll go put those nickels back. Give me 1 second to take care of the ones over here as well. And look, there's 6 dimes all over again. So we'll take each one. 1 for Dan, put it in its spot. 2 for Lincoln in that spot. And then 3 for Miguel. Whew. So you might think we're done, but we actually just divvied up the money properly. Now we need to know how much money each person has. And that doesn't take too much time. It's just writing it out how much each person has. So Dan has this much money. Lincoln has this much money. And Miguel has this much money. And those three blanks should add up to be our $46.80. I'm just going to take a look at see how much each person has. So I see that Dan has, I believe, $7 and then 50 cents and then 30 cents for 80 cents. I think he has $7.80. Let's just double check that. $1, $2, 2 plus 5 is $7. The 25 cents is 50 cents, 60 cents, 70 cents, and then the 80 cents there. Cool, $7.80. You have a couple of options here. You can go through and count up Lincoln's money and then count up Miguel's money. You could utilize the statement that we have here that Lincoln has twice as much money as Dan and just double $7.80. Miguel has three times as much money as Dan and triple $7.80. Whatever feels right for you is what you should do. I'll actually just count what's here. We have 10 cents, 20 cents, 30 cents, 40 cents, 50 cents, 60 cents. I'm already writing down 60 because I see the 4 quarters. That's going to add up to be $1. And so we have that dollar here, $2, $3, $4, $5, $1 ish if we pretend those 4 quarters is $1, and then 2 $5 bills. So that's $15.60 for Lincoln. And then looking at Miguel's wallet, we have 10 cents, 20 cents, 30 cents, 40 cents, 50 cents. Well, let's see if I can't make $1 with those 50 cents. If I take these 2 quarters and these 5 10 cents, I get $1 here. And then I have to take the remaining quarters. I get another $1 here. And then let's see, we have 10 cents, 20 cents, 30 cents, 40 cents remaining. Let's go write down that 40 cents. And then, so we have $15 and $5 bills, 15, 16, 17, 18, 19, 20, 21, 22, 23. $23.40. Like I said, once you know Dan, you could literally just do $7.80 times 2 to get $15.60. And you could do $7.80 times 3 to get $23.40. How I would multiply this, and I'll just explain this for lack of space, I won't be able to write it down. I see it as $7.80. Well, $7 times 2 is 14. I hold that in my mind and think of 80 cents times 2. That's $1.60. Well, $14 plus $1.60 equals $15.60. And similarly, 7 times 3 is 21. 0.80 or 80 cents times 3 is $2.40. $21 plus $2.40 gives us $23.40. Whew. So that was working out this problem visually with the actual tangible pictures of monies. That's one way to solve this problem. Another way to go through this is to interpret the statement that's highlighted that Lincoln has twice as much money as Dan and Miguel has twice as much money, 3 times as much money as Dan. I apologize. So I'm going to take that statement and rewrite it because I think it's really important. It's another visual representation I'm going to give. That Lincoln has twice as much money as Dan, and Miguel has 3 times as much money as Dan. I'm actually going to draw like checkbooks almost, or like bank accounts, I'll say. That's more realistic now. So here's Dan's money. Same idea as the wallet, but I'm going to make like a big chart for everybody. Then we have Lincoln's money. And we have Miguel's money. Well, let's say that if we're just looking at like the blurb of what's on the bank statement, uh, we have Dan's money is this rectangle here, right inside of it. Dan's money, just some arbitrary amount. I don't even know yet. But I know that Lincoln has twice as much money as Dan. So I'll take Dan's money and give Lincoln 2 of them. And I know as well that Miguel has 3 times as much money as Dan. And so I'll take Dan's money and give Miguel 3 of them. So what I'm really dealing with for all of the money pulled together is 6 of Dan's amount of money. This is where the ability to use the algebraic representation is actually going to come into play. So we know that we have 6 of Dan's money is $46.80. Well, just translating this, 6 means the number 6. Of in this context means to multiply. Dan's money, you can use X here. You could use D for Dan's money. You can use M for money, whatever you want. You can even use a $sign if you want. I think I'll use X just because it'll look very different than a 6, whereas a messy D could look like a backwards 6, and I wouldn't want to confuse anybody. So again, that X means Dan's money. Is the equal sign. And then $46.80, you just write 46.80 or 46 and 80 hundredths. So we'd get the equation 6x equals 46.80. You could divide both sides of the equation by 6 by the properties previously mentioned. And you get that x is equal to 7.80, just like before. Well, x represents Dan's money. And if we look at the money statements we drew earlier, 2x equals Lincoln's money. Which is just 2 times 7.80, which we previously found to be 15.60. And 3x is equal to 3 times 7.80, which is equal to Miguel's money. So whether you want to interpret it this way using just straight algebra, that, Dan's money is going to be defined as X, and then define Lincoln and Miguel's money based in terms of Dan's money, solve out algebraically and get the values the same as before. $23.40 for Miguel, $15.60 for Lincoln, and then the $7.80 for Dan. Or you want to interpret it as like boxes of money for Dan, Lincoln, and Miguel, and use similar fashion to think about divvying up the money equally in that way. That's valid. Or if you want to use, the haphazard actual visual representation of money, all three are valid. I'm sure there's many more different ways to work out this problem that we were given. Uh, the story problem of Dan, Lincoln, and Miguel trying to pull their money together and buy a game. If there are any questions, please don't be afraid to reach out. I'm happy to help you as soon as I possibly can. Thank you so much for watching, and I'll see you soon in class. Have a great rest of your day. Bye.